Hey everyone, today we're gonna be doing a Leetcode question which is magnetic force between two balls. So they're saying in a universe Earth C13, Rick discovered a special form of magnetic force between two balls if they are put in a new invented basket. So Rick is saying like there is given some n empty basket and I have one position array where I represent the ith basket. Morty is saying like five, Morty has m balls and it need to be distributed in such a basket. So they are saying this ball need to be distributed in a m different baskets. So such that a minimum magnetic force between any two balls should be maximum. So what this means? Okay. So if I have one ball placed over here in a one position and another ball placed in the second position, their force between both of them will be one. So they are saying, okay, this is the magnetic force of a two balls, like the force, like the difference of a force between them. So if I say, okay, one basket is placed at two, one ball is placed at one. So difference of both will be our force. So if I say one ball is placed over here, one ball is placed over here, so force is one. So what we need to find, like if I placed any m balls, they are saying Monty need to place m balls. So I need to place three balls for this question, and I have my available position 1, 3, 4, and 7. Okay, so I have my basket placed in this position. I need to fill three balls. I will be placing some ball in like some distance apart from each, and I need to find the maximum distance from those minimum distance of a ball. So I'll let you know what that means. Let's see the constant. They are saying position, or you can say length of that position array can go from 1 to 10 to the power 5, the size of n, like 2 to the 10 to the power 5, where like at least two balls will be, the two positions will be there to place at least two balls. Similarly, they are saying the position, like the position of a particular basket can range from 1 to 10 to the power 9, and all the basket are distinct, like there is no two basket at some position. So all the basket will be at a different positions. Okay, similarly m will be going from 2 to 10 to the power 5. Okay, now let's see what this question trying to ask us, like how we gonna be checking, like what is the minimum distance between both the balls and how can we maximize this. Okay, so let's take the first example itself. So the example first, I have this position array. Okay, this is a position array which is given 1, 2, 3, 4, and 7. So if I say, okay, I have some position over here, like this is my basket, like I might have something from 0 to some. But if I say, okay, from this basket, only 1, 3, 4, 7 can be placed. So my 1, 2, 3, or let me mark over here, 1, 2, 3, 4, 5, 6, and 7. So I have this many basket. Apart from that, like only this can be placed. So one can be like this one. I have one basket. Let me make one. So I'll make over here. Okay, I have some basket. Uh, Basket. Okay, this is my basket. This can be placed at some different positions. Like at one, it can be placed. Okay, it can be placed over here. It can be placed at two. It can be placed at three. It can be placed at four, and it can be placed at seven. And rest to position, they are saying it cannot be placed or it is not available. Okay, now they are saying we need to place our ball. I need to place my ball in some position. So I'll say, okay, I need to place m balls. I have m balls. M balls. So m is like in this question it is given m is 3. So I have 3 balls to be placed. Okay, so at least if I say, if I start filling my balls from starting position, like if I place one ball over here, so I might have one ball which will be placed at this position. Okay, now I can place my ball at least like one distance apart from each. So next can be placed over here, next can be placed over here. So if I say the distance between them or force between them is 1 1. Okay, so the minimum force between them is 1 1. So from here, if I have been placed this ball, I got two forces. Okay, from this to this I got one forces, and from this to this I got one forces. So the maximum force from here is 1. Okay, what if I place my next ball over here? Okay, my distance, or you can say the forces now are distributed like this. So for this ball I have force as 1. Okay, the next ball I have force as 2, because if I say my basket is at 4th position, the next ball is at 2 position, so force will be applied 2. But if you see the minimum, see, I need the minimum from these ball. So if I place this 3 ball, I need to find the minimum of them. Okay. So if I place the ball at 1, 2 and 3, if I place my ball at 1, 2 and 3, I got the maximum as 1. Okay. Minimum as 1. Now if I place my another ball over here and some ball over here, and if I place any ball over here or here, okay, if I place something over here, something over here, my minimum will be fixed as 1. If I say this minimum is fixed as 1. Another can be something, okay, this can be something 2, 4, 7, 8, something, but my minimum from here will be 1. So I need to maximize this one. Okay, fine. So let me start filling from here now. So instead of this position, I will be starting from this again. I will be checking each and every positions which will be giving me the maximum force. So for this, I am doing the brute force approach. Like firstly, I'll place one ball, then I'll place the second ball, then I'll place the third ball. So I'll place the third ball for each of the position. Now after placing this ball, I'll try the second position for the second ball. So I'll place my second ball over here. Now third ball will be from here, here and here. Okay, so I'll place that ball over here now. So if I say now my force is 2 for the first ball. So for this ball, I got my force as 2. If I place my next ball over here, it will be 1. If I place my next ball over here, it will be 2. I cannot place over here, so next ball will be placed directly over 7. So I got the displacement as 4. So if I say okay, minimum of this, okay, I'll not place from 1, I'll say okay, minimum from this one, minimum from this is 2, and I'll say okay, I got 2 from where? 1, I got from 1, 4 and I got this from 1, 3 and 7. So I have 3 balls placed in this position, and from that I got 2 as the minimum force. Now the maximum of both of them will be what? So I need maximum of this. Okay, I need minimum of this and maximum of this. So they are asking the question like you need to find the minimum magnetic force. I need to find the minimum magnetic force from any two balls, which should be maximum. Okay, the maximum. So I will be finding this minimum force from each positions. Like I will be filling this balls in each and every position, and I will be checking the minimum force from here. So for now, like I'll place one ball over here, I'll place one ball over here, and I'll place one ball over here. So distance from this is 3. You can say the force from here is 3. Again from here it's 3. Like 4 minus 1 is 3. 7 minus 4 is 3. So if I say okay, minimum from here is 3. And if I say I got one more which is maximum at 1, 4 and 7 position. So for now my maximum force become what? 3 over here. Firstly it was 1. Second it was 2. Now I got is 3 using this particular position. So I'm just checking the minimum force from here. If I took the first 3 basket, my minimum force will become 1 from here. If I have chosen this basket, I need to choose some basket from here. So if I choose the minimum of them, it should give me the maximum force. Okay, so this is what the question is asking us to do. Uh, the brute force approach, like we can place each and every ball and I can get the positions. But if you see now, I'm just starting, like I'm just checking it, like I'm placing all my ball from 0 to some position. I have placed my first ball in the first bucket, then second, then third, then fourth. I am just checking each and every position in a sorted way. Okay, I'm just starting from some range, like I'm starting from this range to this range. So what if like I'll apply something related to this range query, or like if this is sorted, we can apply the binary search. So in order to like we need to reduce this time complexity. We are doing iteration, like we are placing one ball, we are placing the another ball, we are doing brute force. Okay, first place from here, second ball place here, third check over all the position. If it is fine, it's okay. Now again check for the second ball placed over here, third will be placed over here, again over here, again over here. Okay, I'll place my first ball over here, second ball over here, third from here to here. Okay, so I will be checking brute forcely all these M balls. Okay, so this is very brute force approach. We will be using the same approach which we used in the last question. The approach was binary search, like applying binary search on answer. So binary search on answers. Okay, so we have something, we are applying the binary search over that answer. So what we will be doing, so if you see here, we have placed our basket already. So I have this basket placed in a 1 2 3 4 and 7. So for now let's see, like this is in a sorted order. So we'll do the sorting first. So what I'll say, okay, I'll firstly sort my this what to say, the array. So I'll sort my position array. Okay, so I have my position which is sorted. So I will be getting first position as the minimum, this you can say force. So if I say the first two ball, if I pick, it will be giving me the minimum force as 1. So I will be checking and comparing each of them by applying some logic. So currently what we are checking, like we are picking the balls and we are checking the force between them. What if like I'll just pass my force, and if I say, okay, with the given force, can I pick all the M balls? So we will be doing this approach in binary search. We will be like, we have the force given to us, like minimum can be one force, maximum it can be like, if I say the last two, it is having the 6 force. If I choose this two ball, I will get 6 as a force. Okay, so I'll iterate from 1 to 6 in a binary search format. So I will apply all the forces. If I say the second, I'll say, okay, this was the first point. Second, I'll apply binary search from minimum force to maximum force. Now, using that force, let's say like I have my force. Let's take this one separately. So I have this one. Let's come to next page. Uh, undo. Okay, one more. I have this one. I can go from here. Now I'll apply the binary search over here. So in this given array, okay, in this given position array, I will be iterating from minimum force to maximum force. Okay, I have my minimum and maximum force. Okay, minimum force can be 1, maximum force can be like either the last minus first or last minus 1, I can say. So I'll say, okay, I'll say last minus first. It will give me the maximum force a ball can have. Now I will be checking each and every force. So if I say, if I start from force 1, so I can create this ball, I can create this ball. Like I can place one ball over here, another ball can be placed over here because the force between them is 1. So in this approach, I can at least place M ball. So M is given here 3. I need to place the 3 balls. If I place my one ball over here and second ball over here, the force is 1. I can again place my second ball over here. Similarly, I can place all the balls, but let's say like we got the 3 ball placed, which is required in our answer. So I'll say, okay, instead of doing each and every position check, like starting from 1 to maximum force. What if I'll apply the binary search? So I'll say, okay, if I have my range from 1 to 6 over here, so minimum is minimum is 1 and maximum is 6. So let's not try one by one all of them. Let's do the binary search approach over here. So I'll say, okay, find the mid. I'll get mid as 3 over here. Let's say like I got 2 for now. Okay, let's ignore this case. Let this be here. Let's say like I have my mid as 2 over here. So I need to place my 3 balls with 2 to 4s apart from each other. So what if I place my first ball over here? At least 2 forces I need to place this ball. So if I place this ball at least 2 force apart, so if I say I have placed my one ball over here, I need two forces. So I cannot place it over here, but I can place over here. I'll place my second ball over here. Now I cannot place over here my third ball. I need something like more than one. So I can place my second ball over here. Okay. So for this I have two fours. For this I have four fours. Now I got two as a minimum from here. Okay, I got two as a minimum from here. Like I'm not getting two. Like I'm taking my two minimum two forces. So I'm passing like, okay, with two forces, how many ball you can place? I can place all the three ball. That means two is valid. One is also valid. Two is also valid. Now let's take the binary search approach here. So I'll find the mid over here. Okay, I got my mid as 3. So if I get my 3 over here, so I'll place my first ball over here. Now I can place my next ball at least 3 fours apart. So if I say, okay, I cannot place over here, I cannot place over here, I can place over here because 4 minus 1 is 3. So I can at least place with 3 fours apart. So I'll place one ball over here. Now, if you say, okay, one ball is placed, second ball is placed, I need to place at least 3 balls. Okay, so I'll say, okay, fill again. So this is not valid position, this is not valid position, this is valid position. So if I say, okay, 7 minus 3 is 2, 7 minus 4 is 3. So I can place this ball again. So now I have placed all the 3 balls. That means 3 is also valid. Now, every time when you find it is valid, 2 was also valid. So we need to check, okay, what is the next maximum force? So we might be checking for 4 or 5. So let's take like, okay, we are checking now for 4. So every time we will be trying to maximize our force. Now, if I say, okay, with 4 force, I can place a ball from I cannot place over here because distance the force is 1 for here, 2 for here, 3 for here, and this is not applicable, this is not applicable. So I will place my next ball over here, which will be giving me difference as 6. With 4 force I can place 6 force ball. Okay, I'll place one ball over here. Now if you see, if I placed my one ball over here, one ball over here, I cannot place my third ball anywhere. So I cannot apply 4 over here, neither 5, neither 6. So I need to remove my window size, like I need to again shift my ending position or the right position to 1 less. Now I have my start over here, mid also over here, and this will be like terminating my while loop. So we do like while we use our binary search approach like I have while I'll say, okay, I will be iterating from where minimum force to maximum force. Okay, every time I will be checking my mid will be like minimum force plus maximum force by 2. Okay, this will be giving me the midpoint, the like minimum, you can say we are getting the mid value. We will be checking, okay, we will checking if this particular value, okay, I will be creating some function, I will checking if is possible, okay, with this current value. If I say, okay, with this mid, can I create all 3 balls? If it is fine, then I'll say, okay, force is equals to, like, this is our current force, we are just maximizing it. So I'll say, okay, force become mid, and we need to check, okay, next maximum force, like what is the next maximum force I can use to create m balls. Okay, if it is fine, I will be using, okay, just go like mid and mid will be just say okay, I will be doing minimum force will become what, mid plus 1. That means okay, I just need to check for the another force which is maximum to max mid, because here if I say okay mid I got 3, I can create all 3 balls from here. So I need to check okay what is the next maximum force I can use to create another 3 balls. Three need to place another 3 balls. So I like maximizing my force. If it is not a case, like suppose here we got 5 or 3, that means I need to reduce my window size, or just need to make the right pointer, like the maximum force I need to decrement. So I'll say okay, else the maximum force I have, maximum force, it will be like mid minus 1. I need to at least, like I need to reduce my maximum force, so at least all the 3 balls can be placed in some basket. Here if everything runs fine, I will be doing okay, I will be returning my force from here, which I am storing at this particular position. Now this function I will be creating, like for this function I will be checking, I will be placing all balls. So first ball I will place over here, I will be checking the next all balls. So I'll say okay, if this ball and this ball give me force less than, or you can say greater than equals to the past force. So I'll say mid here is the medium force, minimum here, or you can say middle force. So if I say okay, if difference of these two balls give me either equals to or more than the mid force, then I can place this ball. So I'll say okay, placed ball will be plus plus. Whenever I reaches my placed ball equals to the M ball, that means I am able to place my all the balls. If not, I'll return false from here. So let me do a code for here, so you will get like what I'm trying to explain. So let me zoom it a bit. Okay. So for now, I will be creating some function like if possible is possible. So I will be checking is with the current, like in the given position array. Okay, position array with m balls with the given force. So I'll say okay, mid force. I am checking with a mid force over here, or the current force I have. Uh, so if it is fine, if it is possible, return true. If it is not, return false. So I'll say okay, at last I will return false because it is not valid. Now I will be checking okay, my previous, I'll check my every time my first basket will be the previous basket, and we will be iterating from 1 to n. So I will be iterating from 1 to the size of, okay, 1 to size of the this position array. So I will be checking for each and every balls in this position array, each and every basket in this position array, and I will be checking. Okay, so here I need to store the count as well. So at least if I say if I have loaded my previous as 1, like I have selected my first basket, that means at least one ball I can place. So I can say okay, placed will be equals to 1. Now I'll check. Okay, I'll say if my previous, or just check like okay, fifth position of the ith basket minus the previous basket, if it is greater than equals to what, the past difference. So I'll say okay, past force over here, the mid force, if it is greater than equals to mid force, that means I can place one more balls. Okay, if it is possible, then means like okay, I can place at least one ball. Now, if I am able to place one ball, that means I need to like check for the another ball, another remaining balls. Okay, so if I do that, if I say I have placed this ball, what if like I'm not able to place this ball? Let's say like I have placed this ball with some positions, so that time like this will be increasing with one position. If in place this placed ball is equals to m, like while doing this ball placing, if we encountered like all the balls are placed which we required, then we'll return true from here. Okay, true from here. If it is not able to place all the balls, so at last we will be returning what, false from here. Okay, so this will be placing each and every ball we will be taking the first position as the placed ball. I will be checking again for all the remaining balls starting from the next window. Okay, every time I will be checking, okay, if the current basket and the previous basket, if it is giving me difference equals to the mid post or greater than mid post, I will place one ball, and again I'll check if my placed balls are equals to m. So then I'll return true from here. Now if you say, okay, this is just for checking if we are able to place ball or not. Now we need to find the mid. You can say now we need two things over here. We need to find the minimum force, okay, which will be starting from 1, because difference between two ball can be 1 for now. Maximum force will be what? Maximum force will be the, you can say, position array of last value minus the first value. Okay, this will give me the maximum position. Okay, now I need this position array to be sorted also. So I'll say, okay, position array to be sorted. I will be iterating over here in a binary search approach. So I'll be checking, okay, if my minimum force is less than equals to the maximum force, then I need to find the mid force. Okay, I'll say, okay, mid force is what? Minimum force plus maximum force by 2. So I will get the mid from here. Okay, this, like doing this, I will be doing divide by 2, so it will give me the minimum force. I will check if it is possible to get the minimum force, if it is possible to create a place all the balls with the given force, okay, with the given minimum force. So I'll say, okay, if it is possible to place all the ball in this position of a basket with m balls with the given force. So I'll have mid force. If it is possible, then I need to store my force, like the given force or the mid force will be our maximum force for now. So I will be like iterating, and I will be storing all the forces in place. So for now, I'll say, okay, force will be 1, or you can say, oh, 0. A minimum force can be 0 or 1, because at least two balls will be there and two baskets will be there to be placed. So I can say, okay, minimum I can be having 1. Okay, I will be storing all the mid force as the current force. I will be increasing my window. So I'll say, okay, minimum force can be mid force plus 1 now. So I am just checking, okay, one largest force, then the current one. Else, if it is not able to create m balls, if not able to place m ball, I will be reducing my maximum force to 1 less than the mid force. Okay, and at last I will be returning my force from here. Okay, what is the maximum force I can reach? What is the maximum force I can place all the balls? So I'll say, okay, this force is the last force I used to place all the balls. So let me compile this code. So let's see whether it is running fine or not. It's running mid force. Okay, I need to minus over here. Like I need to reduce my maximum force. So let me compile it again. Uh, so let's see it is running or not. This time this Leetcode is very slow. So this got accepted. Let me submit this code as well, whether it is running fine or not. So let me reduce some code. Let me reduce the size as well. Okay. So this code, okay, this is still running. Mm, still running. So it is giving me a error. So I'm not able to, like I'm expected 3 given for, I think we have done one mistake, like we need to create our previous as position of current. Okay, current as my previous again. Let me compile this again. So I will be checking the difference of our last two balls to be placed. Let's see if it is running this test case fine or not. So today this Today this gate code is very slow. Let me compile it again and let me check if it is running fine or not. Okay, this time is accepted. Let me submit this code again. So this is again running. Let's wait for a second. So let's see if we are able to like place all the ball or not. So yeah, this code run fines and it's bit optimized as well. Like we are doing a binary search approach over here. So if I do this while our minimum force is less than maximum force, like we are comparing, like we are finding every time a met. So for this, our time complexity is like log of, you can say the minimum or maximum force. So I can say okay log of n, I can say okay I have n forces if I say in total, like the forces are from 1 to n, so I can say okay I will be using n forces, like log of n forces I can start from 1 to n. Similarly I will be checking again the all n elements, so I'll say okay it will be something like n log n in total. So for this, because we have used order of, like I have used our time complexity of order of n for here, it will be iterated, if, like it will be checked for each and every particular force we are checking in this using binary search, it will be iterated again and again. So the total time complexity will be like n log n. So the final time complexity, the total will be what? It will be n log n. Okay, so it won't be n log n. It will be like n in terms here will be the maximum force we have in the array. So I can have my maximum force ranging from n, but sometimes it not reaches the n. So this we can say okay, it will be n times log of maximum force we have, because we are checking from 1 to maximum force. Okay, so yeah, that's all for today's approach. Yeah, thanks for watching.